Welcome to the YouTube channel Mathematics Student Silver. Now I discuss about complementary function. It is a important part of a linear differential equation with constant coefficient. We know that solution of a differential equation with constant coefficient has two parts. One part is called complementary function and another part is called particular integral. Here I discuss about complementary function, how to find a complementary function of a linear differential equation with constant coefficient, and there are some another videos where I discuss about particular integral. There are mainly three methods. The methods are d operator, method of undetermined coefficient, and method of variation of parameter. Now I discuss about complementary function, how to find complementary function. If after watching the you can understand my video, please like the video and share it with your friends. If the channel is not till subscribed, please subscribe it and say your friends to subscribe my channel to get more video. Let's go in complementary function. We know that the general form a linear ordinary differential equation of order n is that this is a combination of some derivative of dependent variable and independent variable. This is the form here. This is the nth order derivative plus something into n minus 1th order derivative plus something into n minus 2th order derivative plus dot dot something into first order derivative plus something into y, and this is the qx. Here p1 p2 pn and qx are functions of constant or maybe function of x, or it may be constants. In particular, here p1 p2 p are called coefficients. Clearly x is here a independent variable and y is the dependent variable. In particular, if p1 p2 pr are constants, that is the coefficients are constants, then the differential equation is called a linear differential equation with constant coefficient. Okay, let us introduce the operator capital D, where D stands for ddx. The operator where D stands for ddx, that is d of y means here d square means d of d, that is ddx of ddx, that is d2 by dx2. Similarly dq means d3 dx3 plus d4 means d4 dx4 and so on. Okay, therefore capital D of y means dy dx, capital D2 of y means d2y dx2, capital D3y d3y dx3 and so on. Therefore if you put this, therefore there will be dny p1 dn minus 1 y, this is p2 dn minus 2 y. There are two double plus, these are by mistake, sorry for that case. Here dy, here simply p and y equal to q of x. Therefore above differential equation can be written as dn plus p1 dn minus 1 dot dot pn minus 1 d plus pn of y, that is dny plus p1 into dn minus 1 of y plus dot dot pn minus 1 dy plus pny equal to qx. Clearly dy means dy dx, you see that this is p(n minus 1 dy dx). Here p1 dn minus 1 of y, dn minus 1 of y means dn minus 1 of y dx n minus 1, and dn of y means dny by dxn. Okay, so above differential equation can also be written as fd of y equal to qx. Here I write down this expression as f of d. This is actually f of d is actually a operator where fd stands for dn p1 dn minus 1 plus dot dot pn minus 1 d plus pn. Okay, so this is the general form of linear differential equation. In particular, if the coefficients are constant, the differential equation is called constant coefficient, and after introducing the operator d, the constant coefficient, the differential equation with constant coefficient can be written in that form fd of y, where fd stands for that. Here remember that the constants, the coefficients are here constants. Okay, now we want to find the complementary function of such a differential equation with constant coefficient. For this purpose we consider the differential equation fd y equal to q, where fd stands for dn plus p1 dn minus 1 dot dot pn. Okay, now we define reduced equation. What do you mean by reduced equation of the differential equation? Here please remember that this is a differential equation with constant coefficient. This is a linear differential equation with constant coefficient. Now we define the reduced equation of the equation. Reduced equation means you have to put qx equal to 0. Therefore fd of y equal to 0 is the reduced equation of the above differential equation. Reduced equation of 1 is fd of y equal to 0. Here see that we put q of x equal to 0. Here q of x equal to 0, therefore f dy equal to 0. This is the reduced equation of 1. This is homogeneous equation because if you notice that in the left hand side there are power of y dy dx and the other derivatives is 1. But here if you consider this is a function of y, therefore this into y to the power 0. Therefore in left hand side all the powers of y and its derivative is 1, but in the right hand side this is 0. So this is not homogeneous. But if you put qx equal to 0, you can write 0 dot y. Therefore here all the powers of y dy dx are 1, and here if you put 0 dot y, therefore you can say that power of y is 1, but it is not true. But you can still say in that depending on that situation or on that concept, we can say that this is a homogeneous equation. So I write down here this is a homogeneous equation. The complementary function of the equation 1 is the complete primitive of the reduced equation of 1. Okay, what do you mean complementary function? Actually the complementary function of the equation is the solution of that equation. Okay, the complementary function of the equation 1 is the solution or complete primitive or general solution of the equation 2. Okay, that is the equation 2. That is, this is the equation. You see that this is the equation. Actually this is the left hand side of that, and here I put in the right hand side in the place of qx. Actually this is 0. Therefore solution of that equation is called complementary function of that equation. How to find the solution of that equation? For the solution you have to see the video whose name is the solution of homogeneous and linear differential equation with constant coefficient, whose link is given in description box. Okay, if you see that video, then you can solve this type of equation. Okay, now I give some examples to find the complementary function to solve the above differential equation. Okay, actually complementary function is used to find the general solution of a linear differential equation with constant coefficient. Here I consider first example. Find the complementary function of the differential equation d2y dx2 minus 3dy dx minus 4y equal to x square sine root 7x. For finding complementary function, this is not important part. This is actually this is that has no role to finding the complementary function. Solution: the auxiliary equation of the above equation of the reduced equation means we have to put 0 in that place. The auxiliary equation of the reduced equation of the above differential equation is m square minus 3m minus 4 equal to 0. Just put m in the place of dy dx and m square in the place of dy dx2. If this is a third order derivative, then you have to put m cube in the place of d3 y dx3. All of are discussed in the video homogeneous and linear differential equation with constant coefficient, whose link is given in description box. Now we have to solve the complementary function. If we factorize this will be m plus 4 into m minus 4 equal to 0. That is the values of m are minus 1 and minus 4. Therefore the solution or the complementary function will be c1 into e to the power alpha x. This is alpha, this is beta. Therefore c1 e to the power minus 1x plus c2 e to the power 4. Here we consider ab as a constant, where ab are arbitrary constants. Therefore this is the complementary function of the above equation, or it is a solution of the differential equation that equal to 0. Okay, now we consider another example. This is example 2. Here I consider a third order differential equation. Find the complementary function of the differential equation d3y dx3 plus 3d2y dx2 plus 4dy dx plus 12y equal to e to the power x square sin 3x. Okay, solution: the auxiliary equation of the reduced equation of the above differential equation is simply you have to put here m cube, here m, here here m cube, here m square, and here m, and here 1. Therefore m cube plus 3m plus 4m plus 12 equal to 0. This is the auxiliary equation. You have to solve it. If you solve or you have to factorize, then you get m plus 3 into that. Please solve it. Therefore, values of m are minus 3 plus minus 2y, minus 3 plus minus 2y. Since this is a real root, for this root, the complementary contains a into e to the power minus 3x, something into e to the power minus 3x, and plus minus 2y is of the form alpha plus minus I beta, with alpha equal to 0 and beta equal to 2. We know that when the roots are alpha plus minus I beta, then the when the roots is alpha plus minus I beta, the corresponding solution is some e to the power alpha x into some constant into cos beta x plus some another constant into sin beta x. So here alpha is 0 and beta is 2, therefore e to the power 0x, that is 1 into something cos beta x, that is cos 2x plus sin 2x. Therefore CF of the given differential equation is, you see that for minus 3 this will be a into e to the minus 3x, and for 0 minus 2i, that is alpha equal to 0 beta equal to 2. I said that there e to the power alpha x, here that is e to the power 0x means 1, here something into cos beta x, beta is 2, cos 2x plus c into sin 2x. Okay, this is the complementary function of the given differential equation where ABC are constants. Okay, I hope that you understand my video. If you understand my video, please like it and share it with your friends. Please see another videos which are necessary part, and also see the particular integral. The methods are, there are 3 methods which are discussed in my video, and please see the previous video, that is the solution of homogeneous and linear differential equation. If you see that, then you can understand that video, otherwise you cannot understand this. Anyway, thank you.